Alright, so we're going to go into talking about significance tests and the basics that we need to understand on dealing with significance tests. So to start out with this, the first thing we're going to look at is our hypotheses. We haven't dealt with this really before, so our number one topic here we're going to talk about is our hypotheses. Now, you're going to have two to deal with. You're going to have your null and you're going to have your alternative. Okay. There we go. Hypotheses, okay? So we got our null hypothesis. Your null is going to be notated by H subscript 0, right? Now, with this, in this case, for your null, as we've talked about with our confidence intervals and everything else, we've had dealt with proportions and means. So with your null hypothesis, you could have proportions or means as well. So in this case, you would have your mean value or your proportion value, and that would be equal to the null value that's given to you in the problem. Okay? So equal to the null value that's given to you in the problem. Now, with this as well, you can also then, you're going to have your alternative. So your alternative. And so that is your ha, right? Your H subscript A. So your H subscript A. Now in this case, there could be a couple different things with this. So with your alternative, you're still going to be dealing with your mean or your proportions, depending upon the problem. You either have your mu or your proportions, right? But with your alternative, you can either have a one-sided alternative or you can have a two-sided. So one-sided is meaning it's going to be less than the null value or it's going to be greater than the null value. In which case, you would say, let's go ahead and write null value over here. So for the one-sided, you have a less than or greater than. Okay, so again, with this, these two, these are one-sided. In other words, in the problem, it's going to say we believe that the data could be greater than the null value, or we believe the data could be less than the null value. So in other words, therefore, you would know your alternative hypothesis that you're testing against is going to be a greater than or less than sign. However, though, you can also have a two-sided alternative hypothesis because they could just say, what if the value doesn't equal the null value? In other words, what if it's less than or greater than? And therefore, you would simply notate that by saying not equal to. Okay? And for that, on this, we're going to look at, this is going to be, well, I thought I selected that one real quick. Let's see what we got going here. There we go. This is going to be your two-sided. Okay, that's your two-sided. So let's look at this, and we're looking at a couple problems here, and work through them and see what we got. All right, so according to the website, sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep a night. Janie wonders whether this result holds in her large high school. She asks a simple random sample of 100 students at the school how much sleep they get on a typical night. In all, 75 of the responders said less than 8 hours. So with this, what is going to be our parameter here we're talking about, as well as what are going to be our null and alternative hypothesis? So for our parameter here, we're going to be talking about a proportion, right? Because we're looking at 85%. and we're taking 100 students, 75 of them said that you get 8 hours or less. So for this, the actual parameter in this case, our p-value, is going to be students that receive less than 8 hours of sleep, alright, on a school night. So the receive less than 8 hours of sleep. I put my 8 there. 8 hours of sleep. Okay? So you're going to need to be able to explain that. You're going to need to know what you're talking about this. You will need to list this in problems that you're presented with on the AP exam or on just a regular exam for statistics test, okay? You're going to need to be able to list what you're talking about here, whether it's proportion or means. So therefore, I know you know what you're talking about. So, with this, now let's talk about our null and our alternative hypothesis. Well, for our null hypothesis, according to sleepdeprivation.com, 85% of teens are getting less than 8 hours of sleep. So with that, the proportion is going to equal, your null is always going to equal 0.85. Okay? So that's what our null hypothesis is. Now with this on our alternative, so let's look at this on our alternative. Do we have a one-sided or a two-sided alternative? Most of y'all are probably looking at this and automatically saying, well, it's one-sided because it said getting less than 8 hours of sleep. Well, that's right in the study that website did. But what we need to look at here is what the little sample that we actually did by Jamie, what that was referring to. In this case, she says that she asked a simple random sample of 100 students at the school how much sleep they get. Not if they get less than 8 hours, how much sleep they get. So that's the little trick in this one. In which case, she's not wanting to know if they got just less than 8 hours. She's wanting to know if they got less than 8 hours, 8 hours, or more than 8 hours. So with this, the alternative, because it's two-sided, she wants to know just how much sleep they got. They could get less than, or they could get greater than. So in this case, it's a two-sided, not equal. Not equal to 0.85. Okay? So again, read the problem. Really look at what it's asking. They're going to throw things like this at you that make you think one way in the beginning of the problem, and right there at the end, they're going to switch it on you. So definitely pay attention and read the problem. Okay, so let's look at the next one. Alright, so on this one we got, as part of the 2010 Census marketing campaign, the U.S. Census Bureau advertised 10 questions, 10 minutes, that's all it takes. On the census form itself, we read, the U.S. Census Bureau estimates that for the average household, this form will take about 10 minutes to complete, including the time for reviewing the instructions and answers. We suspect that the actual time it takes to complete the form may be longer than advertised. So first off, what are we talking about here? Are we talking about proportions or means? Well, hopefully you see we're talking about minutes, as far as just take 10 minutes all it should take. So in this case, we're going to be talking about a mean, right? Therefore, we're going to be talking about the amount of time it takes to complete the questions, the 10 questions, all right? The survey census right here. So for the mean is the mean time it takes to complete the 10 question census form. we'll just say complete the census form. Alright, so we got our census form there. Now, in this case, what's the mere null and our alternative hypothesis? Okay, so with our null, our HO, we should see that we have it's saying it takes 10 minutes, right? 10 minutes is all it takes. So in this case, you're simply writing your mu is equal to 10, because you got 10 minutes. All right, now for your alternative. Now, they're saying 10 minutes, that's all it takes, all right? However, for what we suspect, and the last sentence here says, we suspect the actual time it takes to complete the form may be longer than advertised. So in this case, with our alternative hypothesis, our H subscript A, sorry, my handwriting is a little cruddy there, but hopefully you can tell it's an A. I'll write that a little bit better. Let me fix that. Otherwise, it'll bug me. All right, there we go. So with this, our mu is saying it's longer than advertised. So we're going to say the average time should be greater than 10. So that's going to be our alternative hypothesis. So again, we're talking about the mu is the mean time it takes to complete the census form, right? In which case our null hypothesis is going to be 10. It's going to equal 10 minutes, that's what we're talking about. And as far as our alternative hypothesis is the mu is greater than 10. All right. All right, so now let's go on to looking at the second part we need to talk about here. So for the second part, let's look at talking about just interpreting the p-value, okay? So the p-value that you actually calculate for this to determine whether you're going to side with a null or alternative hypothesis, we're going to need to interpret that. So for number 2 here, we're going to say for interpreting the p-value. So let's just say the p-value. Okay. The p-value, what that's telling you is that the probability of getting the results it's asking for are more extreme values purely by chance if the null is true. So it's the probability of getting the results are at a more extreme value purely by chance if the null value is true. So one more time, now it's written out here, you can see it. The probability of getting the results are more extreme values purely by chance if the null value is true. That's the key thing to look at, right? So if the null value is true. So I'm going to go through here and let you watch a little video example here of an example problem and see what we're talking about as far as interpreting the p-value.
Hi, this is Jason Molesky. In this example, we'll take a look at interpreting a p-value. Calcium is a vital nutrient for healthy bones and teeth. The National Institutes of Health, NIH, recommends a calcium intake of 1,300 milligrams per day for teenagers. The NIH is concerned that teenagers aren't getting enough calcium. Is this true? Well, researchers want to perform a test of the null hypothesis mu equals 1,300 and the alternative hypothesis mu is less than 1,300, where mu is the true mean daily calcium intake in the population of teenagers. Suppose they ask a random sample of 20 teens to record their food and drink consumption for 1 day. The researchers then compute the calcium intake for each student. Data analysis reveals that x bar, the sample mean, is 1,198 milligrams, and the sample standard deviation is 411 milligrams. Now, after checking that the conditions were met, researchers performed a significance test and they obtained a p-value of 0.1404. So in this problem, we want to explain what it means for the null hypothesis to be true, and we also want to interpret the p-value in context. Well, in this setting, the null hypothesis is mu equals 1,300. This says that the mean daily calcium intake in the population of teenagers really is 1,300 milligrams. So if the null is true, then the teenagers are getting enough calcium on average. Now, assuming that the daily mean calcium intake in the teen population is 1,300 milligrams, there's a 0.1404 probability, or about a 14% chance of getting a sample mean of 1,198 milligrams or less just by chance in a random sample of 20 teens. Recall that when we interpret a p-value, what we're saying is, assuming the null hypothesis is true, here are the chances we'd actually observe a sample value as extreme or more extreme than the one we saw. In this case, that 14% chance is pretty high, so I don't know that we have enough evidence to reject the null, but we'll learn a bit more about that later.
Alright, so hopefully after watching that you saw that when we're talking about interpreting the p-value, it's mainly referring to understanding that the null is true. So we're talking about the probability of whatever we're referring to in the problem for the null, as far as if it was true, what the probability of getting those results would be purely by chance. Alright? So now the last thing we're going to talk about is actually our conclusions that we have to deal with this. Kind of just jumping over a few things here, but we're going to talk about our conclusions, okay? So in our conclusions, we're going to have a simple statement of either we do or do not have convincing evidence against the null. And that is to be mainly dependent upon our significance level. Okay? So your alpha, or as I like to refer to it, as a little Jesus fish, as you can put in there as well. You see the little symbol for the Jesus fish on the vehicles and stuff like that. You can simply say significance level. Cut that. So your significance level is done with your alpha. So again, this is your significance level. So your significance level. And that's what you're referring, or comparing your p-value to, I should say. Okay, so your significance level is what determines whether you reject your null or you accept your null. Okay? So with this, most values, the understood, if it's not given, I should say, if your significance level is not given, the understood value that you should have is going to be your 5%, so your 0.05. So if it's not given, that is the understood significance level. However, significance levels, if they're given, they could be anywhere from 5%, 10%, somewhere in that range. They're normally going to be around that value for the level. Okay? Now, one other little trick here is, before I actually just write out the actual statement again for conclusions, is the big thing, little trick that they say is, if the P is low, reject the hoe. Okay? So in other words, if your p-value, if I can spell it, if your p-value is low, so if it's below significance level, therefore reject the hoe, right? Reject your null hypothesis, because you do have significant evidence against the null hypothesis. Okay, so with that, again, you're looking at if we do or do not have convincing evidence against the null. So again, the overall statement for your conclusion is we do not have convincing evidence against the null. Okay, so again, you need to put in for the null and what all your convincing evidence is as far as the calculations you got. That's where you're going to put in your context. Okay, so what we're talking about in the problem. So don't leave it out. Make sure to actually include that if you're talking about whatever the case may be. Hours of sleep, jelly beans that people eat, whatever the case may be. Something simple, but definitely put the context of it in there for your conclusion. Okay? Alright, so we're going to definitely watch a little video now about talking about these conclusions and how to compare them in significance level.
Hi, this is Jason Molesky. In this example, we'll take a look at the concept of statistical significance. A company's developed a new deluxe AAA battery that's supposed to last longer than its regular AAA battery. However, these new batteries are more expensive to produce, so the company wants to be convinced that they really do last longer. Well, based on years of experience, the company knows that its regular AAA batteries last for 30 hours of continuous use on average. The company selects a simple random sample of 15 new batteries and uses them continuously until they're completely drained. The sample mean lifetime is X bar equals 33.9 hours. Now, a significance test is performed using the following hypotheses. The null hypothesis is that mu equals 30 hours, and the alternative hypothesis is that mu is greater than 30 hours, where mu is the true mean lifetime of the new deluxe AAA batteries. Now let's suppose the resulting p-value is 0.0729. Well, what conclusion would you make for each of the following significance levels? Suppose we looked at alpha equals 0.10. Well, because the p-value 0.0729 is less than alpha equals 0.10, we reject the null hypothesis. That is, we have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average. Well, let's suppose alpha was 5% or 0.05. In this case, because the p-value is greater than alpha equals 0.05, we fail to reject the null hypothesis. That is, we do not have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average.
Okay, so hopefully now you got a pretty good understanding of the basics of dealing with significance test, understanding your hypotheses as far as your null and alternative and how to notate those. Remember, alternatives, you can either have a one-sided, which is less than or greater than your null value, or you have a two-sided. In other words, dealing with is not equal to, so it can be less than or greater than. Also, as well as interpreting your p-value, understanding what that's just telling about the probability of getting the results if the null value is true. And finally, your conclusions, looking at your significance levels. Okay, again, your significance level normally is going to be based around 0.05 or 5%. However, it could be given to you a different value in a problem. But even if it's not given, it'll always be, the fall to is 0.05. And a little trick to always kind of remember saying, if the P is low, reject the hoe, okay? So with doing this, as well in your conclusions, you simply state we do or do not have convincing evidence against the null hypothesis. Again, the null hypothesis you put in your context of whatever you're talking about there, the problem, whatever it's referring to, they give you. Alright guys, so hopefully you learned a little bit something today about significance tests. See you next time.